Okay, so next topic is thermal equilibrium. Okay, so in mechanics, we have already studied mechanical equilibrium. In mechanics, we have already studied mechanical equilibrium. What was mechanical equilibrium? When on a system, forces, all the forces and torques are balanced. Okay, on a system, on a body, all the forces and torques are balanced. So we call, what? That system is in mechanical equilibrium. Yeah, it is an important chapter. Almost 3-4 questions come in this in the NEET exam from this chapter. Okay. So what is mechanical equilibrium? Mechanical equilibrium is what? When all the forces, all the torques on the body are balanced. So we say system is in mechanical equilibrium. Basically, what is equilibrium? What is equilibrium? Equilibrium means all the bodies wants to go in equilibrium state. All the bodies, all the system wants to achieve equilibrium state. This is the most probable state of the body. Like one thing I will give you example. Like you have a cup of tea. So initially it will be hot, but after some time, what will happen? It will become cold. It will become cold. So why it became cold? Because it wants to go in most stable state or most probable state, and that most probable state is equilibrium. That most probable state or most stable state is equilibrium. Why equilibrium? Because our like we can say our ambient temperature or our atmosphere will have some temperature. So that heat from that coffee or tea will move towards atmosphere, and after some time that coffee or that tea will be in equilibrium with the atmosphere. So equilibrium is the most probable state. Most of the system, most of the bodies are found to be in equilibrium. So that is most probable state of the body. Okay, so here I'm talking about and in general about equilibrium, but our topic is thermal equilibrium, so we are going to talk about thermal equilibrium. Okay, so what was mechanical equilibrium? When forces and torques are balanced on a system or on a body. But in thermal equilibrium, what happens? Thermal equilibrium, what happens? When macroscopic variables. Just now I told you what is macroscopic variables. Macroscopic variables like volume, pressure, temperature. Okay, so when macroscopic variables of system do not change with time. When macroscopic variables of system do not change with time. Okay, that means if we have a system consists a gas, so it has some pressure, volume and temperature. Fixed pressure, fixed volume and fixed temperature. Okay, so if that is not changing, then we say that system is in thermal equilibrium. That system is in thermal equilibrium. Okay, so macroscopic variables of system do not change with the time. I'll give you example. See, if we have two systems, A and B, A and B, and both systems are connected with a wall, and that wall is, we can say, insulated wall, insulated or adiabatic wall, insulated or adiabatic wall. Okay, this system is A and B, both are having some gas. Okay, so this gas, A gas, will have some pressure, PA, VA, volume VA. Okay, and this gas will have some pressure, PB, and volume VB. Okay, so when both system A and B are not in direct contact, and there is some insulated wall between them. Insulated means there will be no heat transfer. There will be no heat transfer between those systems. So insulated means there will be no heat transfer. Okay, from A to B or B to A, there will be no heat transfer. Okay, insulated or adiabatic wall. So in this case, we can say, that PAVA and PBVB, any value of PAVA and PBVB, for any value of PAVA and PBVB, both system will be in equilibrium. Understood? For any possible value of PAVA and PBVB, both systems will be in thermal equilibrium. Thermal equilibrium. Why? Why? Because from A to B there is no heat transfer. From B to A there is no heat transfer. That means their macroscopic properties will not change with respect to time. And we can say both systems are in thermal equilibrium. Both systems are in thermal equilibrium. Okay. Now what we will do? Now this insulated wall will replace it by a conducting wall. Now there will be a conducting wall. Conducting wall means conducting wall. This is system A, this is system B. Conducting wall means heat will transfer from A to B or B to A. Now what will happen? Now heat transfer will start from one system to another. From one system to another system, heat transfer will start. Now what will happen? Now PAVA and PBVB will not have any fixed value. Just understand. In first case, this was first case and this is second case. In first case, what was happening? An insulated wall was there between both systems A and B. That means there is no heat transfer. There is no heat transfer. That means for any value of PAVA and PBVB, both system will be in thermal equilibrium because their macroscopic property, pressure volume, is not changing with time because no heat transfer is taking place. Now here what will happen? Now because of conduction, here conducting wall is there, or in your book there will be given diathermic wall. Both are same thing. Diathermic or conducting wall. That means heat can transfer from A to B or B to A. From A to B or B to A, heat can transfer. So in that case, what will happen? Spontaneously, pressure and volume of A and B will start to change. So now both systems are not in thermal equilibrium. Now both systems are in not thermal equilibrium. After some time, what will happen? After some time, a state will reach. Both system after some time, both system will attain equilibrium. After some time, what will happen? As I told you, what is equilibrium? Most probable state or most stable state. After some time, both system will attain equilibrium, and their pressure will be PA dash and volume will be VA dash, and here pressure will be PB dash and volume will be VB dash. Now we can say for pressure PA dash VA dash and for pressure and volume PB dash VB dash, both system are in equilibrium. See, equilibrium means their macroscopic variables like pressure, volume and temperature does not change with time. Do not change with time. So in first case, these macroscopic variables were not changing. So in first case, directly we said system is in equilibrium. System A and system B are in equilibrium. But in second case, when we will replace adiabatic wall with conducting wall, heat transfer will take place. Okay, and heat transfer will take place. So at that instant, systems are not in equilibrium, but after some time, they will attain equilibrium state. And when they will attain equilibrium state, their pressure and volume will not change with time. Okay, so when their pressure and volume will not change with the time, at that time we can say both systems are in equilibrium. Both systems are in equilibrium. I hope all of you understood. I hope all of you understood what is thermal equilibrium. So in equilibrium, there will be how to characterize the equilibrium, thermal equilibrium. In thermal equilibrium, there will be a macroscopic property which is same for both systems. Okay, so for in thermal equilibrium, there will be a macroscopic property which will be same for both systems. Okay, so one thing we understood by thermal equilibrium, when two systems are in thermal equilibrium, there will be no heat transfer between them. We understood, na? When two systems are in thermal equilibrium, there will be no heat transfer between them. That means if no heat transfer is there, that means their temperature is same. Their temperature is same. Now we understood. Now we can conclude that when two systems or when n number of systems are in thermal equilibrium, that means their temperature will be same. But for now we will say when two systems are in thermal equilibrium, their temperature will be same. Simple. Like this gas and this gas system, A and B, both are in contact. So it is having some temperature T1 and it is having some temperature T2. And T1 is greater and T2 is smaller. Like we can say T1 is greater than T2. So what will happen? When both are in contact, heat transfer will take place. From which system to which system? A to B. A to B, because temperature of A is higher and temperature of B is lower. So always heat flows from higher temperature to low temperature. Okay, so temperature of A will decrease and temperature of B will increase. And after some time, their temperature will be same, any common value. So when their both temperature will be same, at that time we can say A and B are in thermal equilibrium. I hope all of you understood what is thermal equilibrium. I explained it in so much detail. Okay. So thermal equilibrium, all of you understood? Clear, na? So you have to remember basically one thing only. When two systems are in thermal equilibrium, their temperature will be same. When two systems are in thermal equilibrium, their temperature will be same. That means there will be no heat transfer between them. Temperature will not change. That means no heat transfer is taking place. So that will be thermal equilibrium of two systems. Okay. So from thermal equilibrium, we can formulate one of the important law of thermodynamics, and that is called as zeroth law of thermodynamics. That is called as zeroth law of thermodynamics. Okay, so we are going to discuss about zeroth law of thermodynamics.